So async iterables. This is from the javascript.info tutorial. Async iterables. Asynchronous iterations needed when values come in asynchronously after a set time or another kind of delay. The most common case is that the objects need to make a network request to deliver the next value. We'll see a real life example later. To make the object iterate asynchronously, the symbol async iterator instead of symbol iterator. The next method should return a promise to be fulfilled with the next value. The async keyword handles it, and we can simply make async next. To iterate over such the object, we should use for await the let item of iterable loop, not the await keyword. For starting example, let's make an iterable range object, and similar like the one before. But now it will return the values asynchronously as per second. As you can see, the structure is similar to regular iterators. Here is a small table with all the differences. So object method provides to provide the iterators in the symbol.iterator and symbol.async.iterator. Next return a value is any value for iterators and promise for async iterators. To loop use for or for here is a for await of. A feature of regular synchronous iterators don't work with asynchronous ones. For instance, the spread syntax will not work. Recall generators. Async generators finally. Under the hood difference. Technically, if you are an advanced reader who remembers the details about generators, there's an internal difference. For async generator, the generator for the next method is asynchronous. It's a different process. In a regular generator, we would use result equal to result of next. Result equal to generator or next to get the values. But in the async generator, we should add await like this. Async iterable range. The regular generators can be used as symbol.iterator to make iterator code shorter. Similar to that, async generator can be used to symbol.async iterator to implement an asynchronous iteration. For instance, we can make the range object generate values asynchronously once per second by replacing synchronous symbol iterator with asynchronous symbol async iterator. So async symbol dot async iterator. Technically, we can add both async iterator and symbol dot iterator and symbol dot async iterator to object. So it's both asynchronously and asynchronously iterable. In practice, though, we would be wired thing to do so. So real life example are the paginated data. So far we have seen some basic examples to gain understanding of the how this real life use case. There are many online services that deliver paginated data. For instance, when we need a list of users, the request to return a predefined count of approximately 100 users. One page and provides a URL to next page. This pattern is very common. It's not about users, just about anything. For instance, GitHub allows us to retrieve commits of the same page in a fashion. We should make a request to fetch in the form https / api.github.com/repos/ the repo name / commits. It responds to JSON 30 commits, and it also provides the link to the next page in the link header. Then we can use a header, use that link for the next request to get more commits and so on. In our code, we would like to have a simpler way to get commits. Let's make the function fetch commits repo that gets commits for us, making requests whenever is needed. So let it care about all the pagination stuff. For us, it will be simple async iteration for await of. For await, let commit of fetch commits, then process a commit. Here's such a function implemented as async generator. Async function star fetch commits, let URL equal to, and then the URL const response await fetch headers. You put the headers. Then we say that const body await response.json. Response the JSON array of commits. And URL equal to next page. For let commit of body until the page ends, yield commit. More explanation about how this works. We use the browser fetch method to download the commit. The initial URL is the commit. The next page will be in the link header of the response. The fetch method allows us to supply authorization and headers if needed. Here, GitHub request user agent. The comments are returned in, commits are returned in JSON format. We should get the next page URL from the link header of the response. It is a special format, so we use the regular expression for that, and we will learn about regular expression in another topic. The next page URL may look like commit, then the operator question mark and page equal to 2. It is generated by the GitHub itself. Then we yield the received commits one by one, and when they finish, we text while URL iteration will trigger making one more request. An example of use shows commit others in console. That's just what we wanted. The internal mechanics of PageNet request is invisible from the outside. For us, let's just an async generator that returns commit. Regular iterators and generators work fine with data that doesn't take time to generate. When we expect data to come asynchronously with delays, their async counterparts can be used. For await of instead of for of. Syntax difference between the between async and regular iterators. Method to provide the iterator is symbol.iterator and symbol.async.iterator. Next return value is value done for true or false. Promise in case of async iterator. Async iterable that resolves value to true or false. Syntax difference between async and regular generators. In case of a generator, the return next will return is a value done of true or false. In case of async generator, it is a promise that results to a value. In web development, we often meet the streams of data when it flows chunk by chunk. For instance, downloading and uploading a big file. We can use async generator to process such data. It is also noteworthy that in some environments, such as browsers, there's another API called Streams that provides special interfaces to work with such streams to transform the data and pass it from one stream to another. Download from one place and immediately sent elsewhere. That's all for now.